Welcome back. I hope you all enjoyed that short break, that you were able to grab yourselves a drink and have some nibble to bite. So let's continue and learn what's the rest of the session covers. Next, we are going to learn about linker script symbol. What are all symbols? Symbols is nothing but every allocated file or the every allocated piece of value will have an address. Inside the linker script you won't have any labels, whereas if you um, give the value, everything will be allocated as an address. So this is what you will see inside. A symbol is the name of an address. For example, my underscore value here is the this address name, the symbol. For this address 800, you can categorize as fun one or whatever. You just name it in your function. So a symbol declaration is not equivalent to variable declaration. What you do in a C application, it's totally different. The linker itself, it's a different language. So you are writing a specific file. Only the target file, the target microcontroller wanted to know. So that's why it's different to your variable declaration. You can also have your own custom symbol. So you can generate, instead of my value, you can also say my underscore add or my underscore address. So likewise, you can create your own symbol addresses. And you can also enter the entry from here where it's going to supposed to live in the memory allocations. So how this memory is stored in code, as you learned that you can't modify anything in flash, so you have to copy the whole data and move to a RAM location, and that's where you can do your modifications, and that's where the startup file comes in handy to move along with the help of these three main things: the end text address, the start of the data address, and the end of the data address. So these three are the main, and this is how you declare a symbol. The symbol values are addresses added by the linker for your variables and functions, and by custom symbol values added by you creating the linker symbols in linker scripts. So you can give your custom values. For example, the 0, 2, and 08, you can give your name, and also the allocation about giving the space, how much you ask the heap to be, and how much you say this stack should be, and that's a symbol table from the generated file. And this is the program that I showed you just while earlier, and this is the symbol declaration. So everything underscore e stack, it's a symbol for this purpose, for memory definition. So that's a symbol. Minus heap, minus, sorry, underscore min underscore heap underscore size, these are the symbol names. Minus sorry, underscore min stack size, this is the symbol declaration. So likewise in this program you will see underscore e text equal dot, so defines a global symbol at the end, and that's the symbol declaration. You have to say the initialization of the reset handler, and that's the symbol declaration you have to say. And how can you assign the symbol value to that symbol? So in the startup, to initialize the data, this is a small piece of code that I'd like to show you. It's underscore s, the start address of the instruction data or the information data. You give that label as a load address. This is how you're going to load that value to this symbol. So load address of dot data, so all the data will be loaded to this via the symbol. And you got keep init and fini, you will learn shortly what they are. And next is the very important thing in the program is location counter. What is a location counter? Being you are using different locations to be storing your data inside the memory allocations, and as you can see when I show you here, everything will be represented in the sections. In the symbol it will start with a dot at the start and finish with the end at the start. It's to give you the location of that addresses where it lives inside the memory allocation. So the location counter plays a major role in allocating the or locating the exact specific address, exact specific point where it lives. I show you in the code that we written the other day in blinking LED. So I'm going to open the flash LED. As you can see, I will minimize this so you know. Okay, we learned about the sections, and inside the sections, as you can see, this is how we group dot text. And if you can see in this, the dot that represents the location counter where exactly this dot text starts, and at the end of the label where it exactly finishes with the dot. So this defines the total area where the dot text lives. So that's where the location counter is important. So likewise, the RO data where it starts of that RO data, read only data, and where it finishes with the dot, with the location where it finishes. So likewise, everything you will have the start and the finish, the start and the finish location, the start and the finish location, everything will start with the dot. So this dot is really important, just to let the controller, the microcontroller knows that where that memory allocation, where that data text information is kept inside the memory location. So that is nothing but the location counter. This symbol is called location counter. Since linker automatically updates this symbol with location information, it has to pinpoint that particular location where it's going to stay. And you can use this symbol inside the linker script to track and define boundaries of various sections. So when you give the dot, it creates a boundary where the start and where the end is. So that's where your memory allocation sits, and all the information dot text dot data belongs to that, and it will sit in that location, the boundary. You can also set location counter to any specific value. You can do that by writing linker script, and that's the modification you can learn to do. You can also customize it and say instead of there, you can also say it can stay in a different place. And because only in the sections we the compiler or the object files groups through with the form of linker, it creates a sections, and that's where the location counter is used. The other areas it's not used, it's only in the locations. And the location counter is incremented by the size of the output section. Depends on the output section, it increments its size. And this I just explained you in the code. Dot text stores the updated location under counter value in the symbol. So this is to give the boundary of dot text. It starts from here and ends here. So, and all this information lives between that boundary. Next we're going to learn about align command. Again, it's a command, so therefore its name has to be in upper cases, capitals, to align the start of a section to a required boundary. That's what it does. So it aligns and makes preparation to have that particular dot text or dot data. So it aligns and it tells the compiler to know that that area is aligned and it's only used for dot text purpose, and this area is aligned and only used for dot data purpose. Also, it give you a pad section to get a required size. So by aligning, you can't modify that area, so that's specifically given for that category. The read-only data here as an example given is aligned by word size on the 32-bit architecture and directed to your data section. For a 32-bit machine, it typically needs to be word aligned. So all the word will be aligned, depends on the boundary that you created. By giving the location counter, it creates a boundary, and inside this boundary you need to align your data line by line. So by saying align of 4, this 4 represents the byte boundary size. There can be 8 byte as well, but this one it's a 4 byte, so that's why align of 4. So it knows to allocate and gives the addresses and align that in that particular RO data section. So that's what align command is. You aligning the addresses of variables, the section names that you are using, dot RO data, it aligns and categorizes inside that boundary that you created through the help of location counters. So that's what align command is. And the align command, this is the important thing you shouldn't forget. The align command will start with the start align and it will have the end align. So when you start, don't forget to write a finish or an end. Otherwise, the RO data will be not knowing where to be kept, and therefore you will get to see number of errors. So to do that, you have to, if you use a 4 byte there, you also end with the 4 byte. If you use a 8 byte there, you have to end with the 8 byte. So please make sure the structure is like this. You have to have a start and an end. Next we move on to learn about what is a keep command. As you can learn from the definition, the keep statement within a linker script will instruct the linker to keep the specified section without untouched, meaning even if there is no symbols inside, when it comes into terms of compilation, the STM32 compiler will do its maximization to optimize it so that you can get the speed and everything booted up goes well. So by saying a keep inside the boundary, inside the align, it won't disturb that particular information that inside. Although it will be inside the linker script, it is there, but it won't do anything. It will just keep it for references. Even though that align or that ISR vector hasn't been referenced to another part of the program, this won't be changed. So it just kept there, and the compiler may think that that's not used in any part of the program, so why should I keep it? I'll erase it to give you more space. But by keep, it could be an important information for everyone to know. So a keep is to keep those information handy for everyone and tell the compiler not to optimize that. So that's why the keep command is. You have to write keep of star asterisk dot interrupt underscore vector, means that for this section optimization must be skipped during linking, so it won't optimize. So that's the keep command. The next one is .init and .fini. .init represents the runtime initialization, whereas .fini explains to be the termination of that runtime. In a code, respectively, if you take this .text in that code, if you give keep init and find init, this initializes the information and then it terminates by keeping that. And inside the text, as you can see, there is a .text and .text asterisk. So what that means, .text will group all the .text values and put it in there. And .text is to merge everything and put everything into one, and it may have a different file names accordingly. The data section, for example, data.test, it will be all grouped into this asterisk. So this is how the linker grouping terminology is used. If it is .text with an asterisk, that means the compiler knows that it has to bring every file name that says .text will be grouped into that. So that's what the init and fini, it will be happening in the runtime. So to initialize, to start the data grouping, and then once it finishes, if you put fini, then it terminates and comes out of the code block. So that's what init and fini uses for. Then there is pre-init underscore array, init array, and fini array in linker scripts. These are mainly used inside the array. So the pre-init array and the init array sections are pointers to be used on initialization. So it's a pre-initialization and the initialization inside the linker script. The fini array is an array of functions that will be called on destruction. So After initialization, if you want to terminate your program, and that's where the fini array is used, telling the compiler that it's finished and it wants to terminate and come out of the program, and that's where the fini array is used. You will see this in the code that we learned to write the other day on blink LED. If you come there, that's the init and fini. So this is that, and if you keep going, scrolling down, inside the flash memory, that's where the the initialization array inside flash, and the initialization array, and then the fini array. Once it finishes, it comes out of here. That's where those two are used. And inside the data sections in RAM, so dot data indicates the current address. All symbols has to end with a semicolon. So that is very important. When you classify the symbol, and if you give that a location counter, if you don't, this is the general syntax format you have to write to declare the data sections. It has to end with the semicolon. That's the point. Otherwise it will get a compilation error and runtime error, so please make sure you have a semicolon at the end. Now we just saw in the code, in the align command, greater than RAM at greater than flash, and we already know through the build analyzer in the memory definitions, memory details, you get to know if it is stored in RAM allocation, then it's called virtual memory address. If it is stored in flash allocation, it's called load memory address. An at command is you saying the compiler where it has to be stored, where it has to be located and loaded. So in this piece of snippet I would like to show, we are saving saved flash addresses AT, data flash. So that's where you're going to use greater than symbol and give the name at RAM or flash. If you see that in program that we learned to write the other day, and this is what that at symbol is, at RAM at flash. So you saying dot data can live both in RAM, and it can also saying it can live in flash as well. So likewise, this .bss, it is located and lives only in RAM. So that's where the greater than symbol is. Likewise, user heap stack, it's in RAM. The discard, likewise the data, it's in RAM and in flash. The fini array, it is in flash. The arrays all kept in flash. So the greater than symbol is telling the compiler where that data is kept, basically. And this is how I just explained. The flash means those sections are in flash, RAM means those sections are in RAM. So greater than flash, these sections lives inside the flash. Greater than flash, these RO data lives inside the flash. And if it is RAM, this .bss, the initialized and uninitialized global variables, they all kept in .bss, block started by symbol section, and RAM of user heap lives in the RAM section. So this is the greater than symbol. And the RAM function, to access the RAM function data, this is the syntax you got to use. Dot RAM function attribute to allow the linker to specify that the function is to be placed in and executed from RAM. So we also learned that you can also keep the executable file in RAM as well. If you want to run your program from RAM, you have to use this .ram func, the syntax, so that you can run the program from, you can run the microcontroller, whatever the blinking LED, for example, you can save that in the SRAM and you can start to compile from the SRAM also. So that's the function you have to use, .ram func. And discard section. Discard section is used to define memory regions that are out to be discarded during the linking process. These regions can include either object files or libraries that are needed by the final program. So in this example, you just have a piece of information which says discard, and that's how you have to write. I have to write backslash and with discard in capitals, and it has to end with the semicolon, and you need to give whether it's a library, what type of library, math library, library GCC, library C. And if you discard, so these files, the compiler knows that you don't need that to execute in the final program. So therefore, they just get erased or removed from the section. So that's where discard is used. Sometimes, for reference, we keep a lot of libraries inside the program for everyone to understand, or it can be used in other part of multiple file projects. In that case, if you use discard, then it won't occupy a lot of space in your program code. It will take away everything that and it doesn't mean to keep. So that's what it is. Discard is. And inside the arrays, as you can see, there is a provide hidden message. So the provide hidden is a directive that's used to create a hidden symbol, which is a symbol that's not visible on object files or any libraries when the program is linked. For example, there are keep of instructions in other languages. So likewise in here, if you write provide hidden and then give information after that, that will be hidden. For example, if there is any encrypted data that not to be seen visible to others, so you can keep that inside the provide hidden, and that will hide when you start to run the program, and the linker won't alert or modify any of that. It knows that that's important value or important information. The linker will automatically know that you shouldn't or it shouldn't touch that part, and it will skip that and move to the next part. So before we going to summarize, I'm going to go back to the program that we just learned, and I'm going to take you through line by line so that you understand what a linker script is, and you would be able to write your own linker script when you use in a project. So as we learned, by default, when you set up the project name, when you start to do the compile, the first build and debug process, it generates the STM32 generates both the flash linker descript and the RAM linker description. The RAM file is mainly used for debugging purposes because that's where most of the data lives all the time, so it's used only for debugging. Whereas Flash, you can have both the program memory and the data in there, so that's the linker description lives in there. So anything on the top with slash and asterisk, that's a reference for all to understand. And if you go to show view and show build analyzer, this is the memory regions. As you learn how the memory you have to declare in the definition with the RAM and the flash, with the origin, that's the origin, and the length 128K, 128K and 512K. You have to define that, and you have to start with the command. The entry command is first you telling the compiler where the target controller has to start from. So you're going to start that from the reset handler, meaning it has to help keeping the data value in the stack format. So that's where it starts, the entry point. Then you come into memory and you're defining the memory, what sort of memory you're going to use. You can also link with high definition memories like SDRAM or DDRAM, DDR2, all those you can also interfere. They are high speed. But if you include, and you have to give their attributes and say what that is used for, and also its starting address as the origin and its capacity, its space. Then followed by memory. These are in the correct order, so don't change this order, otherwise the compiler will throw a lot of error. So memory follows sections. You learn from start of file creation, you return the own ISR vector, and this is the sections where it summarizes and groups dot text, dot arvo data, dot everything, BSS. And then with greater than symbol, you learn that you allocating that where to be living, and dot with the start and dot with the end, dot with the start and dot with the end, that represents the location counter. It creates a boundary for that particular section, so nothing can be included in that section. That's only meant for dot text. And when you say align, then it aligns accordingly to the byte count. So it's a 4 byte count, so likewise it will arrange accordingly to 4 bytes. And keep is to keep inside, no matter what, when it wants to optimize, it will still keep all the information. And init, dot init is for initialization, and dot finish is for termination. You tell the compiler that it's finished, come out of the code, so you use both of that. And then if you scroll down, you got pre-init array and init array, and they all live inside the flash memory. And provide hidden is some important information that the linker doesn't have to be touched, so that's why you keep something inside provide hidden. And then fini array, it's the termination array. And then you have the symbol loading address point. The data is going to load to this SI data through a load adder, and this is a symbol. So dot adder dot data, and you giving the start location counter and the end location counter. You're going to use to run from the RAM location. So to run the program from the RAM location, you need to use dot RAM function. And you learn dot data asterisk means it groups together all those files that says dot asterisk and groups it and put it here. And then likewise the same with the BSS, dot BSS align, and it lives in RAM. Likewise user heap and stacks are in discard. These are all the files that you don't want, and we haven't used any attributes in this. And this is how a startup file generates by itself, but you can write your own startup file, because now you know what is involved and what is there inside the in the linker script file. And if you go deeper into the memory details, and you will see the sections of it inside the memory region. That's a memory definition. And if you click on to memory details, this is under window, show view, and you have to choose build analyzer, so you get this. So the virtual memory address, whatever allocation that you asked it to store in the RAM, that's called virtual memory address. And the flash memory, whatever you asked it to load into the flash memory, it's called load memory address. So it saves all this data in here. And as you can see, flash, it can be both LMA and VMA, but both of the addresses are the same, but RAM has a different address, and it groups the sections into categories with .isr, .text, .ro data. So what we learned today so far, we learned about what is linker script and where it is used and how it is used. And also you learned about the different linker script commands, about starting with entry, and you finished with discard, all of that. So those are all commands. And what is a location counter? What is the purpose of the location counter? And also you had a elaborated understanding about each and every sections, every thing that's linked with the linker file. And I'm sure with this information now you can go and create your own linker description file. In bigger projects there will be sources where they concentrate only when they work with large amount of data, then the linker description file is really must. For simple project, the auto generated from the compiler will do, but if you work on a bigger project, then writing own linker description file to do that will be a good choice. But you got to know this knowledge. Without this knowledge, if you simply go and change, for instance, how about I go and change the stack value on this, so that may affect something. So that's why I got you through and walk you through the whole concept. So now you are more familiar about each and every concept, so you can go and create your files, linker description file yourself. As I said, you have to also develop your mindset as well. When you develop your skill, mind plays a big role in towards your success. So don't whinge about things. What that means is don't always throw things at other issues or other people or other ways. Take things on your hand. Like if you fail, then look for opportunities to a way that you can make that to a success. Instead, don't always be in a whinging mode, telling things that it's not going your way, it's not working. and that's a negative frame of mind that won't lead to any success. So stop whinging about your situation. Instead, look for opportunities and work towards it to be a better and a successful person as you are. And also, the second point I would like to point out to you is always see good in people. When you see good in people, they will immediately see the good in you. No one is perfect, including me. Everyone has their advantages and drawbacks. So if you only point out the good things in other people, they will only point out the good things in you. So even though if you are bad, they won't focus on that. They will look on the positive things. So positive frame of mind will create anything and do wonders. So please be like that, and also consider others to be considered like that. And please to get into the involvement, so don't stop it, because this motivates each other, and also we are all trying to help each other to learn this. Write your top 10 goals to get a point, and write 10 top 10 ideas to actually thinking to achieve that goal will get a point. And spend at least 30 minutes to do exercise, and go for a walk at least 10,000 steps, and will give you 2 points. At least spend 15 minutes to meditate to clear off your mind, so take away all the worries and the stress, come back and refreshed, and you will have plenty of energy in you to learn. And 10 minutes to visualize actually achieving those goals, and 10 minutes to focus for the rest of the day activities, or what's going to happen tomorrow, or for the week. So you have to yourself set yourselves to be in that way. And 2 hours of learning will fetch you 2 points, because you are in the early stages of learning. So 2 hours at least to spend and taking notes will get you 2 points. This is just a fun activity, so that please post your involvements in the group, so everyone can see where you are up to and learn and motivate with each other. And the end goal everyone has to work is 10 out of 10. So please get involved and do that. And there is combo internship coming your way. You learned about the beginner modules, and now we are in the intermediate modules. To learn the whole M4 series, you need to go for the advanced as well. So please invest on this information that I'm passing on. It's well worth for a lot of value, and you get a lot of value. And getting this 30 days and having that hands-on experience opens up opportunities for you. And you can also create and learn to do your own projects, and you can sell your own projects, make money. Or if you want to really work for big companies, and this will help you to clear that first hurdle, get into the interview, clear the interview, and get into the job. So please invest. And also stay tuned. These are all in process and progress. Once it's all ready for your learning, you will be the first person to know. So please stay tuned with us, and you'll get to learn and upskill yourself and learn a lot more. So you will be an irreplaceable asset in any team. So the more you have it, the more irreplaceable you can be. So that's why you need to update, even if it is a small step every day. Update yourself, upskill yourself. I take this opportunity to thank each and every one of you. I thank you personally from the bottom of my heart. Thank you for your patience to learn through today's session, and go and enjoy that lovely break from the screen that you've been staring at for last few minutes or so. And I wish you all to have a great and a lovely, fruitful, productive day. It is Arul Anbukarasu. I'm signing off on behalf of A2DG. Huru for now. I'll catch you at the next session. Until then, take care. Bye bye. Have a lovely time, and I'll catch you in the next session. Bye for now.